Good afternoon. Welcome back. Last time we are doing sums on sets. There are a few sums which contain ordered pairs. So we will take up those sums and then we will move to the today's chapter on functions and relations. Okay. So let us take this example, the 31st example. The E is given and the subset of E satisfying 5 plus x to be greater than 10. So they have given us a set and they want us to find a subset. So let us try and do that. Now, let us see. What is the condition that they have given? 5 plus x should be greater than 10. Okay. Now, can I take any numbers? No. I can take only numbers that are given to me in the set E. Okay. So, if I take the first number, if I say 5 plus 1, which is equal to 6, is it greater than 10? No. So, I will not have this number in my subset. Okay. Then I will say 2, 5 plus 2. Okay. Because 5 plus x, so I will put 2 as x. So, this is equal to 7. Is it greater than 10? No. Then 5 plus 3, which is equal to 8. So, this is also not there. 4 plus 5 is also not there. Now, coming to 5 plus 5. 5 plus 5 is 10. So, is it greater than 10? No, it is equal to 10. It is not greater than 10. So, we will not even take 5. Now, 6 plus 5 is 11. So, our required subset. Okay, so the required subset will be equal to 6 because 6 plus 5 is 11, which is greater than 10. Then 7 because 7 plus 5 is 12, which is greater than 10. 8 plus 5 is 13, which is greater than 10. And 9 plus 5 is 14, which is greater than 10. Okay, so this will be your required subset and then we will click this as the correct answer. Okay, now let us move to the 32nd sum. Okay, they have given us the relation A minus B union B minus A and they have given us the sets A and set B. Then they are asking you to find out a triangle B. Okay. So, you can do it in both methods. So, A triangle B means what? If I use the given formula, that is A minus B union B minus A. Okay. So, if I'm using this, I will find A minus B. What does A minus B mean? It means I have to write down all the elements that are present in A but not present in B. Okay. So, what is A minus B? Is 1 present? No. So, I will write this. 2? No. 3 is present and 4 is not present. So, okay. So, only 3 is the number which is also present in B. So, I am writing down all the elements of A which are not present in B. Okay. Then we will do B minus A. Now, what does it mean? What are the elements in B which are not present in A? So, we know 3 is already present in A also. So, what are the elements? 5 and 7. Okay. So, I have found out A minus B. I have found out B minus A. And what I have to do? I have to do the union. So, this is equal to what? I'm going to write down all the elements of A minus B and B minus A. So, this is 1, 2, 4, 5 and 7. Okay. So, this is the answer. So, this is the correct answer. 1, 2, 4, 5, 7. So, A will be the correct answer. Okay. Now, let us go to the AQB 13th sum in AQB. Okay. So sometimes you see all these big numbers, big thing written in in the options, and you start feeling, oh my God, will I be able to do it? Yes, you will be able to do it. You don't have to worry. We will just check. What are they asking us? They have given us set A, set B, and set C. And they are asking you to find the relations and find out whether it is a null set or not. See, first option is A intersection B is not equal to a null set. B intersection C is not equal to null set. A intersection C is not in a null set, but A intersection B intersection C is a null set. Okay, here they have given all this permutation and combination. So what we will do is we will start with A intersection B intersection C. Once I know whether that is an null set or not, it becomes easier for me to find out because that will eliminate one or two options. Okay, so let us see. I have A intersection B intersection C. Now, what are the numbers which are common to both A, B, and C? What are the numbers which are common to all the three sets A, B, and C? Now, here I can see 2 and 3 are common to A and B. Okay, I can see 2 and 3 are common to A and B, but I don't find them here. Okay, in C. 3, 2 and 3 I could find out. 1 is common between A and C. Again a problem. 4 is common between A and C. But as you can see, there is no number which is common to all three, A, B, and C. Okay. So this is a null set. A intersection B intersection C is a null set. Okay. So that clearly means that C is not an option because they are saying it is not a null set. But we know it's a null set. So C has gone. Now I have to see whether A or B is a correct option. Else we will have D as the correct option. Okay. So let us see now. A intersection B. Do I have any numbers which are common to both the sets A and B? A intersection B, I can see here that 2 and 3 are common. So A intersection B is 2 and 3, which is not a null set. Okay, which is not a null set. So therefore, because here in B they are saying it is a null set. So therefore, this option is also not correct. Now I have to check whether A or D is the correct answer. Okay, so for that, let me go to the next. That is B intersection C. B intersection C. Let us see. Are there any numbers? Let me take another color so that you can see. We are now trying to find out B intersection C. Are there any numbers which are common to B and C? 2, 3, no. 7, yes. I can see 7 here also and I can see 7 here also. 9 in B also and 9 in C also. So 7 and 9. Okay. So I can see that this is also not a null set. Okay, so this first condition is satisfied. A intersection B is not a null set. B intersection C is also not a null set. Now let me find out A intersection C. Okay, let me find out A intersection C. Are there any numbers which are common to A and C? 1, yes, 1 is common here to A and C. And then 4 also is common with A and C. So I will write down A intersection C as 1 and 4. So which is not a null set. So the third condition is also satisfied. And A intersection B intersection C is 5. We already have found out. So this. So therefore the answer for 13th is option A. Okay. So option A is the correct answer. Clear? Okay. Let me check. Yes, Avdesh, good afternoon. Pooja, Ishan. Yes, Chaitanya, Durgesh, Lakshita. Yes, Divya, Zebba, Rohan, Sangeeta, Bhargavi, Bihu, Kushdeep. Yes, Ananya, very good. Devesh, yes. Yes, Devesh, what you want? Yes. Power set. Okay. Power set is what? It is a collection of all the subsets of a set, that is power set. Okay, Devesh? Pratina, what does it mean? It means that there is at least one element in the other set so that it becomes a proper subset. If A is equal to B, then we say they are equal. Okay. But when there is at least one element in the other set that is not present here, then we say it's a proper subset. Okay. Yes, Bibika. Very good. Yes. Isha. Thank you. Yes. Harshita, Bhargavi. Good. So this is clear now. Okay. Crystal clear? Yes. Now let us go to the next sum. If the universal set x belongs to n, that is x is a natural number and x lies between 1 and 12. Less than or equal to signs are there. Okay, so that means you will take that number also because there is an equal to sign also. So this is the universal set. So what are the numbers? 1, 2, 3, 4 up to 12. A is given to me, B is given to me, and C is given to me are the subset of X. Then the set A union B intersection C is. Okay. So we will always follow the BODMAS rule. We will first solve the bracket. Okay. So this is the 14th sum we are dealing with. So what is B intersection C? Okay. What are the numbers which are common to B and C? Is 2, 3 present? No. 4? No. 6. Okay. I can see that 6 is present in B and C. Okay. No other numbers. So this is 6. Now A union B intersection C. What is the value of A? 1, then 6, 9 and 10. Okay. So this is the answer. So B is the correct answer. So B is the correct answer. Okay. So when this type of sums are given, remember to solve the bracket first. Remember to solve bracket first. Okay. Now let us go to the next sum. As per question 14, the set A union B intersection A union C is. Okay, let us first find out A union B and then A union C. Okay, what is A union B? A union B for the 15th sum is 1, 3, 4, 6, 9, 10, 11, 12. And then A union C, isn't it? For the 15th sum, they're asking us A union B and A union C. So let me find out A union C. 1, 2, 5, 6, 9 and 10. Okay. Now what is the 15th sum saying? It is saying A union B intersects with A union C. So I want to find out the intersection. So intersection means what? Which are the common elements? Okay, let me check the common elements. 1 is common, then 2, 3, 4, 6 is common, 9 is common, and 10 is common. So I have this to be equal to 1, 6, 9 and 10. 9 and not 11, this is 10. Okay. So In this case, B will be the correct answer. 1, 6, 9 and 10. Okay. Okay, this is appears to be a big sum, but only here what we have to do is we have to write down. What is it saying? A sample of income group of 1172 families. Okay, 1172 families were surveyed, and notice that for each of the groups, that is, this is the salary for people with salary less than 6,000, then salary between 6,000 to 10,999, then 11,000 to 15,999, and 16,000 and above. Number of TV sets available are. So they have done a survey. In the survey, they have seen what is the income of the family, and then they have asked them the income, and then they have asked them how many TVs do you have. So in some households, there were no TVs, so 0 TV, then 1 TV or 2 TVs. Okay, so they are trying to see 2 or more TVs. So they are wanting to understand whether there is a relation between income and number of TV sets in the household. Okay, so let us see this. So I have less than 6,000, less than 18,000, 6,000 to 11,000. Then we have, okay. Okay. So now let me just put it over here, because I will have to write them down. We'll just copy the question from here, from the textbook. So salary, this is for salaries. This is less than 6,000. Then 6,000 to 10,999. Then 11,000 to 15,999. Then more than 16,000. Okay. And here I have zero TV sets, 1 TV set, 2 or more TV sets. Okay. This is TV sets. Okay. So I'm just using this information that they have already given over here. Okay. So we will see, we will write it down. Okay. So this is 70, 152 and 10. This is 50, 308 and 174. This is 20, 114, 84. And then this is 50, this is 46, and this is 94. Okay. Now I have totaled this. Okay, you can do it yourself also. This is 190, this is 620, this is 362. Okay. And the total on this side, this is how much? 232, 532, 218 and 190. Okay. And remember this, all total should come to 1172, which is the number of families. Okay. Now what are they telling us? Set A is what? Set A is a family owning 2 or more sets. Okay. So I will write here 2 or more. I'm going to write this as, this is my set A. Okay. families having 2 or more TV sets is the set A. Then B is the set, is a family with 1 TV set. Okay, so B I'm going to write over here. Then C is a family with income less than 6,000. So this is C. Then D is a family with income 6,000 to 11,000. D is this. And E is the family in E is the family between 11,000 to 15,000. Okay, so this is E. Okay, so I have now got this. So A is the families, is the set of families with more than 2 TV sets. B is the families with 1 TV sets. C is the family whose income is less than 6,000. D is the families with income between 6,000 to 10,999. And E is the set of families with income 11,000 to 15,999. Okay. So now what are they asking us? Okay, find the number of families in each set, C intersection B and A intersection E. C intersection B, C intersection B and A union E. Okay. A union E. Now C, where is my C? C intersection B. Okay. This is a C. Okay. And this is my B. Okay. This is my B and this is my C. If I go from here towards my right, and if I come down, what is the number here? 152. Okay, so C intersection B is equal to 152. Now they're asking you to find out A union E. Where is A? A is here. Okay, so moving from here, I have A. A union, so E. What does union mean? That we take everything along. Okay, so what are we going to do? We are going to add everything. So I'm going to add this plus this plus this, and then I'm going to add 20 plus 114 and plus here. But I'm not going to add 84 twice. Okay, so I'm just going to add it once. So I'm going to add 10 plus 174 plus 84 plus 114 plus 20. So that is 402, which is missing, plus 84, 94. Okay, this is A. Okay, so only this has to be used. Remember to use once. Okay, otherwise what happens? By mistake we add everything. Plus 94. So answer is 496 is equal to 496. Okay, which is the option? Do I have that here? 156. Okay, yes. So D is the correct option. Okay. Now, as per question 16, find the number of families in each of the following units. A union B dash intersection E and C union D. Okay. So I think once you've understood this much, this is more than enough for you that you will be able to do them. Okay. This is a limit to which you will be asked the question. Okay. Now let us. Yes. So that finishes up till here. Okay. Yes. So let me stop and let us move to the. I hope you've understood this question. Okay. Because 17th is very lengthy, we won't need that. Yes, very good, Bhumika. Armand, you can easily join this. You have to just go to the BCC ICI and then you can join from there. Okay. If you're watching it on YouTube, you can join from BCC also. Okay, Pratyushna, we will do that. Okay. Tejashri, these are in the additional question bank. Yes, Diksha, correct. You need to know the concepts clearly. And then, very nice, very nice. Yes, Zeba. Khushi. Okay, so let us now move to the chapter on. Now we are going to talk about functions and relations. Okay, we are going to talk about functions and relations. Now, what do you understand by relation and what do I understand by function? So let us try to understand this. Any subset of the product set xy. Okay. So A is equal to 1, 2, 3. And B is equal to AB. Then if I want to find the product set AB, that is 1A, 1B, 2A, 2B, 3A and 3B is the product set. Okay, this is your product set. So any subset of the product set xy is said to define a relation from x to y. Okay, so this is defining a relation between x and y. Okay, so from this product set, if I take only this much, 1A, 2B and 3C. Okay, if I take only this much, no, there is no C, no? Okay. If I take only this much, then we say that this is a relation from x to y, and in this case, A to B. And very important, and any relation from x to y in which no two different ordered pairs have the same first element is called as a function. In which no two different ordered pairs have the first element is called as a function. Okay, so in this case, this will be a function because in these ordered pairs, what is the first element? It is 1. And what is the first element in this pair? It is 2. So they do not have the same first element. So then we say that it is a function. So in which no two different ordered pairs have the first element is called as a function. Okay, so let A and B be two non-empty sets. Then a rule or correspondence F we write it. So when we write the function, we will write it as an F. F is such that A to B. Or we call it as a mapping. We call it as a function or mapping. Okay, the word used is mapping. The element fx of B is called as the image, while x is called as the pre-image of x. Okay, so elements in B are called as image and elements in A are called as pre-image. Okay, and if the function is defined, then A is called as the domain of F, while B is called as the codomain of F. And the set FA, which is X belonging to A, is called as a range of X. Okay. So let me show you that from this you will be able to say that all functions are relations, but all relations are not functions. Okay. So if I have here 1, 2, and 3, and if I have here A and B, okay, and if I put this here like this and like this, then here sometimes you can even have like this. So here what we say is this is called as, let me not take two. Okay, for a function, then this is your domain. And this is your codomain. These are your images. And these are your pre-images. Okay, 1, 2 will be the pre-images. Okay, now if I write this 1, 2, 3, and then I'm writing A and B, then this is the codomain. And this, not here, this is the range. Okay, this is the range and this is the codomain. Okay. This is the case where we have both the elements here. But suppose I may have this, then in that case, what will happen is that I will be able to write them as codomain and I will be able to write it as range when they are the same. If they are the same, I can do that. If from a B, I'm selecting something which is satisfying the condition, then I say that it is the range. Suppose here I have A to be equal to 1, 2, 3. Okay. And I have B, which consists of 1, 4, 5, 6, and 9. Okay. And if I say the function is such that if the function is y is equal to x square, okay, if the function is such that y is equal to x square, then in this case, if I write 1, 2, 3 here, then here out of this B, what can I write? For 1, what is the square? 1. For 2, what is the square? 4. For 3, what is the square? 9. Okay, so then this 1, 4, 9 is called as a range. Okay, and this is called as a codomain. Okay, so in a rather than the first example, the second example makes it easier for you to understand. Okay. So this is your range. Now let us go to the different functions. Okay, these are the very important functions. One function, onto function, bijective function, identity function, constant functions, equal functions. These are the different terms that you should know. Now, what is the one function? Okay, one function. If the function is from A to B, if different elements of A have different images in B, then F is said to be a one or an injective function. So, one is also called as what? Injective. Now, onto, which is also called as surjective, what does it mean? It has that B has at least one pre-image in A. That every element of B has at least one pre-image in A, then we say it is an onto function. Okay. Then, and when it is onto, then we say that the range is equal to the set B in this case. So suppose here, instead of B having 1, 4, 5, 6, 9, if my B was 149, then I say that it is an onto function because every element of B has a pre-image in A. Then bijective, a 1-1 function and onto function is said to be a bijective. What is a 1-1 function? That each element of A has a different image in B, then it is a 1-1 function. And if each element in B has one pre-image in A, then we say it is an onto function. So a function in which each element of A has an image in B and each element of B has a pre-image in A, then we say it is a bijective function. Identity function, the function I defined by A going to A. Okay, so for all x belonging to A is called as a identity function. Okay, identity function is always a 1-1 and onto function, with the domain of A being the range A also, because the function is from A to A. So domain and range will be A. Now into functions. What did we say in onto function? In onto function, we said that every element in B has a pre-image in A. What happens if it is not so? What happens if I have at least one element in B which does not have a pre-image in A? Then we say that it is an into function. When do we say that it is an into function? There exists even a single element in B having no pre-image, in A, then we say it is an into function. Okay. Then concept of constant function. Let f be going from A to B defined in such a way that all elements in A have the same image in B, then f is said to be a constant function. Okay. All elements in A have the same image in B, then same image in B, then we say it's a constant function. Okay, you need to just know these because then you will have some 30 question there. You should be able to quickly tick that all elements of A have the same image in B. Okay. Equal function. Two functions f and g are said to be equal, written as f is equal to g if they have the same domain and they satisfy the condition fx is equal to gx. Okay. So when do we say they're equal? Then they have the same domain. Okay. Inverse function. If f be 1-1 onto function from A to B, then let y be the arbitrary element of B, then f being onto, there exists an element in x such that fx is equal to y. Okay, if x is equal to y, then we say it is a inverse function. And a function, what is the condition to know whether a function is invertible? That is, we can find the inverse is if and only if it is a 1-1 as well as onto. Means what? Every element of A will have an image in B and every element of B will have a pre-image in A. Only when this condition is satisfied will there be an inverse. Okay. So I've just given you the short forms in which you can remember. Just read through. Mohammed, what do you want? What is A union B? What is pre-image? Mohammed, what is pre-image? Pre-image is the elements of in the set A. What are the elements of set B called? They are called as images. And corresponding to each element of B, what is the element in A? When we want to find out, that is called as pre-image. Okay. Okay, you have to type only once. So now 1, 1 onto many 1, bijective, surjective, constant, equal and inverse. We have considered all this. We will just put it in short. When I am talking of 1, 1 or an injective, which means that every element of B will have a different image. Okay, so remember the word different image in B. Onto is every element of B will have a pre-image in A. Bijection means which is 1, 1 and onto. Bi means 2. So what are the two qualities that function will have? It will be 1, 1 as well as onto. Okay. What is surjective? Which is an onto function. It is called as surjective. What is a 1, 1 function called? It is called as an injunction function. Then what is a constant function? Where every element of A will have the same image. What is an equal function? F is equal to G. What is the condition? That they must have the same domain. Okay, then we say they are a equal function. Inverse function is possible. This is a very important theory question. Inverse of a function can be found out only when the function is a 1, 1 and an onto function. Okay. See, I've shown you here. This is a 1, 1 function. Okay, so every element of A has an image in B. Okay, but can you see over here? Okay, can you see over here? Let me use a different color. Okay, is there any element in A which does not have an image in B? Is there any element in A which does not have an image in B? No. Every element of A has an image in B. Okay, because I can see this first star going from here to here, second going from here to here, third from here to here, fourth from here to here, and fifth from here to here. So this is a 1, 1 function. Did you notice that here there is one element in B which does not have a pre-image in A? Okay, so but this is a 1, 1 function. Why? Because every element of A has an image in B. What is an onto function? Let us see this example. Every element of B has an image in pre-image in A. So you can see here, this is A, this is B. As you can see, every element in B has a pre-image in A. So here also you can see that there is one element in A which does not have an image in B. But here what happens is we are talking of every element in B having a pre-image in A. Okay, we are here talking about pre-image. And so this is satisfied. Okay, onto. Then bijective we are showing, which is both 1, 1 and onto. So here from here we can see every element of A has an image in B. Okay, first star, second star, third star, fourth star, fifth star, and sixth star. Every element of A has an image in B. And what about pre-images? Here we can see that every element of B has a pre-image in A. So then we say it's a bijective, that is 2. So 2 qualities are what? A, every element of A having an image in B. And what is the second? Every element of B having a pre-image in A. Okay. Then we are talking about different types of relations. Asha, this is already uploaded. Okay. The PDF is uploaded. Geetanjali, what do you want? Disjoint. Okay. See, Geetanjali, disjoint means what? Disjoint set is that is there is nothing common between the two sets. Okay. Like I was telling you, if you have a bag full of potatoes and the second bag contains oranges. Will there be a relation between them? Can I say that one potato is one orange? There is no relation. Okay. So that is why when we say this, then we say that it is a disjoint set. But suppose I have one set of natural numbers and I have a second set of squares of the natural numbers, then there is a relation. Okay. Then I can say there is some relation between them. But we are talking of disjoint sets. So in this disjoint sets, what happens is that we talked about yesterday. We talked about, suppose I am a teacher who teaches accounts as well as business studies. Okay, then in a college you will have teachers who can teach both, right? Some teachers will teach accounts, some teachers will teach business studies, and some teachers can teach both. So in that case, when there are some teachers who can teach both, then we say that the sets are not disjoint. But if I have if I'm trying to find out teachers who can teach accounts also and who can teach, say, biology also, okay, in a commerce college, if I have that, then if I have a set of teachers teaching biology and if I have a set of teachers teaching me accounts, so are there any common teachers? No. Then we say that the two sets of teachers is disjoint. Okay. So that is the example for disjoint set. Okay. Hope you've understood, Gitanjali. Right. Now we are talking about different types of relations. There are three types of relations. Relations can be reflective, transitive, and symmetric. Okay. Relations can be reflective, transitive, and symmetric. So if I have the set A, B, C, be any set, then the relation R is a subset of the product S cross S. Okay. Now the relation R containing all ordered pairs of the form AA is in S cross S is called as a reflective. Okay. What does reflective mean? That I can see myself, reflection. Okay. In the mirror, what happens? If you stand in front of the mirror, you can see yourself. Okay. So same thing. This means what? It is reflective means AA. Okay. Suppose I have S to be the set of all faces of a dice. Okay. All faces of a dice. Okay. So if then I know what are the numbers I can have, 1, 2, 3, 4, 5, 6. Then if I have S cross S, so what will that be? It will be 1, 1, 1, 2, 1, 3, okay, 1, 4, and so on. Then you will have 2, 1, 2, 2, 2, 3, and last will be 6, 6. Okay. Then if I want to have a reflective relation, then what will it contain? It will contain 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay, so I have rolled 2 dice. I have rolled a dice and get 1, 2, 3, 4, 5, 6, and I take the product S cross S, and then when I want to see a reflective, then I say this is of the form A in S cross S, then we say it is reflective. Okay, so what is here in our example? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Now, if AB belongs to R and BA belongs to R, for every AB belonging to S, then S is called as symmetric. So if AB belongs to R and BA also belongs to R, then we say it is symmetric. For example, A is equal to B implies B is equal to A. Okay. If I write down A is equal to B, that means what? B is also equal to A. So hence the relation is equal to is symmetric. So relation is equal to So A equal to B is a symmetric function. What about A greater than B? If A is greater than B, does it mean B is greater than A? No, it does not. So if I write 5 is greater than 2, does it mean 2 is greater than 5? No. Okay, A greater than B will not mean B is greater than A. So this is not a symmetric function. Okay, so equal to, it becomes a symmetric function. Now, if A, B belong to R and B, C belong to R, such that AC will also belong to R, then for every A, B, C belonging to S, R is called as transitive. What this means is that something satisfying AB and something is satisfying BC, which if it means that it satisfies AC, then we say it is a transitive function. Okay. Simplest example is equal to. If I say 3A is equal to B and B is equal to C, won't it apply what it imply that A is equal to C? Okay. If A is equal to B and B is equal to C, then it means that A is also equal to C. Any relation which is reflective, transitive, and symmetric, we call it as an equivalence function. Okay, so we call it as an equivalence function. Let us take this example of parallel. Okay, parallel lines. Is A parallel to itself? Yes. Is A parallel to B? A parallel to B. Does it mean B is parallel to A? Yes. If one line is parallel to another line, doesn't it mean the other line is also parallel to A? Yes. Now, if I say A is parallel to B and B is parallel to C, if I say A is parallel to B and B is parallel to C, won't it imply that A is also parallel to C? Yes. So then we say this is an equivalence relation. Okay, I've drawn it here. I have a line A, I have a line B, and I have line C. If I say A is parallel to B, and if I say B is parallel to C, then it will automatically mean that A is also parallel to C. Okay, right? Now let us take some examples so that the picture becomes more clear. Okay, understood till now? Yes. Okay, now what has happened is you are given two sets A and B, and then you are asked which of these relations on A to B are functions. Okay. So what is a requirement for a function? Okay. What is the requirement for a function? Let me show it here. What is the first thing we talked about? That no two different order pairs have the first same element. When that happens, then that relation will become a function. Then no two different order pairs have the same first element. So let us see over here. No two different order pairs have the same first element. Now here I can see first element here is x, first element here is x. So this cannot be a function because no two ordered pairs, different orders pair will have the same first function, first element. Now here also you can see y is here also and y is here also. It's here also, okay? In this case, this is also not a function. Now we have to check whether b or d or both are both are functions, okay? Now let us see the first this thing. What is it? X, y, and z. What are the first elements in this? X, y, and z. They are different. Yes. And so this is a function. Now this is x, y, and z in D also. So we say this is a function. So B and D will be a function. Okay, just let me know whether you have understood. Yes, Bhargavi, yes. Himanshu, if you just go through the videos also, you will be able to cover up, okay? Yes, Isha, we will have a break in 5 minutes, okay? Yes, Zeba, yes. Paranita, okay. Hi, yes, we will have a 5-minute break. Okay, thank you. Yes, welcome back. Okay, so here we were discussing the sum in which we have taken the definition or understanding the concept of function, which says that we will have each element to be separate. The first element will be separate. So in A and C, we could see that the element X is repeated in A, the element Y is repeated in C. So that means it is not a function. So B and D will be the functions. Okay. Now somebody was asking what? Just a minute. Pratinna, you don't have to worry. They will give you that option where two options are correct. They will give you that option. Usually they will have it in written in proper way. So you don't have to worry. Yes, Bhargavi? Khushi, what you'd want me to tell you? Asha, B and D both are correct. Okay, in that case. Okay, in this case, these examples are only given for you to understand. Okay, so in the exam they may give you the option. You know, in the MCQ they will give you the option. Only A is correct. Okay. Then they will give you the option B and D are correct. Okay, that type of answer you will have. Okay, so don't worry, don't fixate on that aspect. Think about whether or not you've understood the concept. Okay. Now let us see this. The second thing they have given to us is okay, I will just show you through an example. 1, 2, 3, 4, and 5. And this is 1, 2, 3, 4, and 5. Okay. What is the relation? X plus y is equal to 5. Now, if I have x as 1, what is the value of y? If I have x as 1, then y will be 1 plus y is equal to 5. So, y will be equal to 4. So, 1, 4. Okay, this is my point. Then x plus y is equal to 5. I put y, x is equal to 2. So, 2 plus y is equal to 5. Y is equal to 3, 5 minus 2. So when x is, because this is the x-axis and this is the y-axis, I hope everybody knows that. So when x is 2, what is the value of y? It is 3. Now what will happen when x is 3? What will happen when x is 3? X is equal to 3 means y is equal to what? 3 plus y is equal to 5. So y is equal to 2. So when I have x as 3, y will be equal to 2. Okay. Now when x is 4, y will be equal to 1. So when x is 4, y is equal to 1. So as you can see that this is a straight line. This point has not come out well, but if we have a good graph paper, then I can see this. Yes. So you can see this. So what is happening? For every value of x, there is a distinct value of y. Okay, for every value of x, there is a distinct value of y, and then we say it is a 1-1 mapping. Okay, then we say it is a 1-1 mapping. Okay, understood this? Because see here, it is important is that it is all real numbers. So here I can see that for every value of x, I'm getting a clear value of y, and so this is a 1-1 mapping. 1-1 mapping means the same. Like we have shown it above also. Okay, 1-1. Can you see over here? Every element of A has a separate. Can you see? Every element of A has a separate. Every element of A has a separate image in B. Okay. So that is 1-1. So here also in a given example also, we can see that every value of X has a distinct image in Y. Okay. So we say it is a 1-1 mapping. In relations and functions, whenever you are in doubt, the trick is to draw the graph. Okay, graph आप side में बना लीजिए. You will be able to see that over there you can find out whether it is a 1-1 function or not a function, or it is an onto function. Okay, that you can do. Okay. Now x is equal to 4. You have a function, you have a relation x is equal to 4. Now let me see. One, two, three, 4. Okay. 1, 2, 3, 4. What does it mean? If my value of y is 1, what is the value of x? It is 4. If the value of y is 2, what is the value of x? It is still 4, isn't it? Because x is equal to 4 is given to me. What is the value of x when y is 3? It is again 4. Well, what is the value of x when y is 4? It is 4. So what are we getting? We are getting this line. Isn't it? We are getting this line. So what is happening? For different values of B, we are having same value of A in A, okay, or same pre-image. Okay, for every element of B, we are having same pre-image. But what does the function say? What does the definition of the function say? Okay, let me go back again. I want you to understand this very clearly. What does the definition of function say? That no two different ordered pairs have the same, no two different ordered pairs have the same first element. No two different ordered pair has the same first element. And what is happening over here? What is happening here? 4, 1, 4, 2, 4, 3, 4, 4. Okay. So every ordered pair has the same first element, but the definition of function says only when they're in the relation that no ordered pair has the same first element, then only we say that it is a function. In a relation, when no ordered pair has the same first element, then we say that it is a function. But here you can see clearly that every ordered pair has the same first element. So therefore, this is not a function. Okay. So it is not a function. Understood? Let me check. Yes, Asha, here also what is happening is, here we can see that if I put the values of x, I will find out the values of y. See, if I'm putting x as 1, what is the value of y I'm getting? It is 4. If I'm putting x as 2, what is the value of y? 3. If I'm putting value of x as 3, what is the value of y? 2. If I'm putting the value of x as 4, what is the value of y? 1. Okay. Here, can you see that if you're comfortable with this, go in like this. So you can do it by this method, draw the graph, or you can put it in ordered pairs, or you can put it like this. So if this is my x and this is my y, and I have the value 1, 2, 3, 4. For value of x, and here 1, 2, 3, 4. 1 and 4 form a pair, right? Then 2 and 3 form a pair. Then 3 and 2 form a pair. And 4 and 1 form a pair. Okay. So as you can see that here you can see that every element, there are no ordered pairs which have the same first element. Okay. So you can see, or for every element in Y, you will see that there is a distinct image in A, pre-image in A. Okay. Hope Asha you've understood. Now let us go to the next one. Yes, very good, Pranita. Very good. Now let us go to the next one. Y is equal to x square. Okay, y is equal to x square when x and y belong to R. Now, can anybody tell me what the answer is? Yes, Kushdeep, you got it? Very good. Can you solve this for me? Yes. You've got the answer? Yeah. Okay. Let us see. Now let me put the values of x and c. Okay. Y is equal to x square. Let us put the values. See, you don't have to worry. You have to just put in the values and see. Let me put x as 1, 2, 3, 4. What will be the value of y? Y is x square. So 1 square, 1. 2 square, 4. 3 square, 9. 6 square, 4 square, 16. Isn't it? So, is it a function or not? Now tell me. Is it a function or not? Because what is important is x and y belong to the set of R. Okay. X and y belong to the set R. Yes. Let me know. Excellent. Oh my God. Yes, Himanshu. Yes. Says Preet. Says Preet, what is happening? That it is a real. X and y are real. So that is why in this case it is a function. Okay. Yes. Yes, Himanshu, because it is a real function. Because x and y are belonging to the real set, therefore this is a function. Okay, therefore it is a function. Is that clear, all of you? Yes. Yes, Aditya, yes. Aditya Darshan, yes, it is a function. Bhumika, correct. So Sonil, correct. Yes, Pratidnya, Lisa, Mehpreet, very good. Yes, Khushdeep, excellent. Okay, yeah. Let us now go to the next sum. This is 9th to 13th. Okay, we are taking sums 9th to 13th in the set 7th-B. Let the domain of X be the set 1. What is the domain? Domain is the first set. So what is the set saying? They are saying that domain is 1. Which of the following function gives the value equal to? Okay. Now domain is equal to 1. Now for the first option, I have taken only 2 options are there. Oh, okay, here. Let me do this sum here. So third option is here and fourth option is here. Okay. So domain is 1. Now for the first option, let me put, what does it mean that value of x? What does this mean? This means that value of x is 1. So in this question, put x is equal to 1 in all the 4 options. Okay. Put x is equal to 1. Now what will fx give? F of 1 will give what? 1 square. 1 square is how much? 1. What does g of 1 give? G of 1. 1 is 1. So these values are same, right? Over here, let us see. F of a is equal to f of x. I think they want to write x. F of x is equal to, that f of 1 is equal to 1. Then g of 1 will be equal to 1 minus 1. Is it? 1 minus x. So 1 minus 1. What is the value? 0. Is 1 equal to 0? No. So this is not the correct option. Now let us check this also. I will put x as 1. So this is 1 square 1 plus 2. How much is this? This is 4. And this is how much? 1 square plus 1 plus 2. And this is 1 plus 1, 2 square. Okay. So you will get here that okay, which of the following functions gives a value equal to 1? They are asking you to find out equal to 1. So here you are getting one value, f of x is 1, but g of x is 0. So B is not the correct answer. What about C? C, f of x is 4, g of x is also 4, but we want equal to 1. So this is also not the correct answer. So we will have, in this question, we will have A to be the correct answer. Is that clear? Now let us go to the 10th sum. Okay. Now let us see, what is the 10th sum? F of x is equal to, okay, f of x is equal to 1 upon 1 minus x square. Now they want you to find out f of minus 1. What does this mean? It means put x is equal to minus 1. So put x equal to minus 1. So if I put x equal to minus 1, what will happen? F is equal to minus 1 is equal to 1 upon 1 minus of minus 1 whole square. What is the square of minus 1? Minus 1 square will be plus 1. Okay. Okay, not square. It is not square. Yes, thank you. So, f of 1 upon minus into minus is plus 1 plus 1. So half. So what is the answer for f of minus 1? It is equal to half. So B will be the correct answer. Clear? Yes, understood this sum? Yes, Himanshu. Says Preet? Correct? Okay. Okay, let me finish this and then we will go back to more questions also that you have. Okay, Saraspreet? So g of x is this much. Now g of x is equal to x minus 1 upon x. What do they want you to find out? G of minus half. Okay. So instead of x, I'm going to write minus half. So this is minus half minus 1 upon minus half. Okay. How much is minus half minus 1? This is equal to minus 3 by 2. And how much is this? Minus half. Okay. Now, as you can see, you have minus in the numerator and minus in the denominator. Minus upon minus will become plus. Okay, so this becomes plus. 3 upon 2 upon 2 upon 1. Either you can directly do this. So this will get cancelled and you will have 3. Okay, answer is 3. If you can't do this, you can simply do this. Minus 3 upon 2 is how much? Minus 1.5. How much is this? Minus half. It is minus 0.5. So on the calculator, if you divide minus 1.5 divided by minus 0.5, you will still get the answer as 3. Okay. Okay. Next is this. Now you have to understand this concept of composite function. This is f of g and g of f. What does this mean is, you're given two functions in x. First function we call it as f, second is g. Then in the first function, I will substitute for the value of x the second function. Okay, I repeat, one function is f, one function is g. Then for every x in first function, I will substitute the second function, that is f of g. In g of f, we do the opposite thing. In the second function, we will substitute the first function. This will become very clear when we do the sums. Okay. Now f of x is equal to 1 upon 1 minus x, and g of x is equal to x minus 1 upon x. Now you are asked to find f of g. So wherever there is x, I will write the function g. So 1 upon 1 minus. So instead of x, I am writing the function g. So this is x minus 1 upon x. Okay. I will simplify this. Okay. So wherever there is x, so here in this example, you had only one place where you had x. So this is equal to 1 upon, this will be x minus 1 upon x. Okay. Denominator of the denominator will go to the numerator, right? We already know that, x upon. And now we will open this bracket in the denominator, x minus x plus 1. So this minus plus x minus x will get cancelled. Plus x and minus x will get cancelled. And you are left with what? This is equal to x upon 1, which is equal to x. So A will be the correct answer. Okay. So here important thing is that I first see where is the x. This is my x. So instead of x, what am I going to write? I'm going to write this whole thing. So I have written. So wherever red is there, you can understand that has been substituted. Okay. Understood this, sum? Yes, Bhargavi, very good. Yes. Yes, Zeba, very good. Manshu Param. Yes, very good. Sanjay. Yes, Bhargavi. Good, good. So let us now go to the next sum. Now here they are asking you to find out g of f. In this first example, we have found out f of g. Now we will find out g of f. So fx is equal to 1 upon 1 minus x, and then gx will be equal to x minus 1 upon x. Then we have g of f. So wherever there is x in g, we are going to write down f. So where do we have? Here and here. Okay. So I'm going to step, instead of x, I'm going to write down the function of f. So this is 1 upon 1 minus x. 1 upon 1 minus x minus 1. So g of f is equal to upon, again I'll put the red, so that you know you will be very clear. You will never make a mistake. 1 minus. Now this is equal to, okay. Wherever there is x in g, I am going to write down the function of f. So once I have written that, I'm going to simplify. This becomes 1 minus x. This is 1 minus 1 minus x upon 1 minus x. Now what is this? If I open the bracket, 1 minus x plus x. So this is x upon 1 minus x. And this is 1 upon 1 minus x. So fraction in the denominator will be flipped. So this is x upon 1 minus x into 1 minus x upon 1. So this 1 minus x will cancel with this. Answer is x. So in this case, B will be the correct answer. Okay. Have you got this now? Yes. Yes, Shalini. Yes, Sonali, very good. So we have got this answer as x. Okay. So what we have to understand is what is this function? What is the whether it is an onto function, into function, bijective function? These are simply names, you know, that we have. Okay, let us now try to find out the inverse function. F inverse of fx is equal to 2x. Okay, so here, okay, now I have f of x to be equal to 2x, f of x to be equal to 2x. Now what this means is, I'm to find the inverse, I will write this as y is equal to 2x. I will write it as y is equal to 2x. And then I will take x on the left hand side. I will take x on the left hand side. So what will x be? X will be equal to y by 2. X will be equal to y by 2. Once I have done that, then I write f inverse of x is equal to, instead of y, I'm going to resubstitute at x. F inverse of x is equal to x by 2. So for the 16th, x by 2. So B will be the correct answer. Okay. I'll do it again. Okay. What is the function given? We are doing the 16th sum. Function is given to me as fx is equal to 2x. What is the first step to find the inverse of a function? The first step to find the inverse of the function is writing fx as equal to y. So write fx to be equal to y. So y is equal to 2x, right? Then what is the next step? Next step is write x on the left hand side. Write x on LHS. So x will be equal to y by 2. X will be equal to y by 2. What is the third step? That I will write f inverse of x will be equal to, so third step is substitute y to be x. So x upon, so f inverse x is x upon 2. So B will be the correct answer. Now let us see the 17th sum. F of x is x plus 3, g of x is x square, then f of g is how much? Okay. So let me try to do it over here. Fx is equal to x plus 2 and g of x is equal to x square. What are they asking? F of g. Wherever there is x in the f function, we will put the value of g. So f of g will be equal to, instead of x, I'm going to write down x square plus 2. So what is the f of g here? X square plus 2. Or x plus 3. 17th is, it is x plus 3. So x square plus 3. So 17th, A will be the correct answer. So f of x is x plus 3, then g of x is x square, then f of g will be in every x that is present in the f function, I'm going to substitute by g. So what is the g function? X square. So I've substituted by x square. Now they have given you fx, they have given you gx, and they are asking you to find out fx into gx. What will be fx into gx? X plus 3 into x square. So what will this be? I multiply x square with x, so this is x cube, plus x square into 3, so this is 3x square. So what is the answer for the 18th sum? X cube plus 3x square. Is that clear? Now they are asking you to find out inverse when hx is equal to log x to the base 10. So you have done this, the chapter on logarithmics. So now you know that this is equal to, what will be the inverse of this? Okay, so what is inverse of this? Y is equal to log x to the base 10. Okay, so I have to write x. X will be equal to 10 raised to y, or f inverse x will be equal to 10 raised to x. Okay, so for 19th, it is equal to this. This is because, remember, in logarithmic, this is what? This is the exponential form of logarithm. Okay, if you did not understand here, that means you did not pay attention in that chapter. Go back to that chapter, see exponential form of logarithms. In the that you will see this function. Okay. Okay, let us see. Hx is given 10 raised to 1 plus x. Then the values of real values of x, domain of real values of x, when x belongs to 0 to 9, the range is given by. Okay, now, okay. In the 20th sum, let us see what they're asking. They're asking you to find the range. Okay, have you understood till now? Yes, Anshu, Himanshu, yes. Now, what is h? What are we saying? H is equal to 10 raised to 1 plus x. Now, what does this mean? This is how much? They're asking the real value. So, when x is 0, what will be h? H will be equal to 10, right? And what will happen when x is equal to 9? What will happen? H will be equal to 10 raised to 1 plus 9, which is equal to 10 raised to 10. So, what will be the range? It goes from 10 up to 10 raised to 10. The range of this function goes from 10 to 10 raised to 10. So, you will have A to be the correct answer. Okay. We will have. Why 0 is not possible? Because it is 10 raised to 1 plus x. So, even when you put 0, you will always have 10 raised to 1 plus 0, which is equal to 10 raised to 1. 1 plus 0 is 1. So, therefore, it is 10. So, don't make that mistake. Okay. And this is 10 raised to something. Right? Hope you've understood. 7.15. Madan with some 15. Okay. Madan is asking for question number 15. Okay. They are again asking you to find the range. Okay. Now let us see. Now let us put what is the value of x? Minimum value is 0, maximum is 9. Okay. When x is equal to 0, what will fx be? Fx of 0 will be log of 1 plus 0 to the base 10. Okay. Instead of x, I have substituted 0. So this is equal to log of 1, because 1 plus 0 is 1 to the base 10. Okay, to the base 10. Okay. Log of 1 to the base 10. everybody knows log 1 is how much? Log 1 is 0. So what is the value? This is 0. So f of 0, okay, f of 0 I have found to be equal to 0. Now let me put when x is 9. Okay. Let me find out when x is 9. What will happen? This will be equal to log to the base 10, 1 plus 9. 1 plus 9 is how much? 10. So this is equal to log 10 to the base 10. What is log 10 equal to? Log 10 is equal to 1. So f of 9 is equal to 1. So what is the domain? What is the range for the domain of real values when x is between 0 to 9 is 0 and 1. Okay. So A will be the correct answer. Okay, 0 to 9. Then is that clear? Yes, Pranita, Bhumika, Zeba. Yes, Harshita. Okay. Yes, Isha, we have taken the 20th sum also, right? We have already taken that. Okay, we have already done that. Okay, this is what I was talking about yesterday when we are talking about A cross B. Okay, we've already done that. So if A is 1, 2, 3 and B is 2, 4, 6, then we will say A cross B is equal to what? 1, 2, 1, 4 and 1, 6. Then I will start with 2. So this is 2, 4, 2, 2, 2, 2, 4, 2, 6. And then I will have 3, 2, 3, 4 and 3, 6. Okay. So A cross B will be this much. Okay. Now we are taking an example of the identity function. Okay. As we talked about identity function, identity function is A. So we have here, if I have the set A is equal to 1, 2, 3, then identity function will be equal to 1, 1, 2, 2 and 3, 3. Okay, this will be the identity function. Okay. Inverse function, we have just now calculated inverse function, right? Okay. Okay. So if we have A is equal to 1, 2, 3, then if I have this function R is 1, 1, 2, 2, 3, 3 and 1, 2, then it is it reflective and transitive, but it is not symmetric. Why? Because 1, 2 is not equal to 2, 1 here. Because in this given example, 1, 2, okay, here you can see that 1, 2. When do we say it is the same? Because 2, 1 should also have been included over here. But do we have 2, 1 here? No. So it is not symmetric. Okay. 1, 2, but 2, 1 is not there. 1, 1, is it reflective? Yes. 1 reflects 1? Yes. 2 reflects 2 and 3 reflects 3, but it is not symmetric because when we have 1, 2, but we do not have 2, 1. Okay, we have done this. We've talked about ordered pairs. We have talked about Cartesian product of sets, function relation, one-to function, onto function, bijective function, identity function, constant function, equal function, inverse function. Yes, we've talked about all this. Then we have talked about different types of relation, reflective, reflexive. Reflexive is that when we have AA types of pairs, then we say it is a reflexive function. When for AB implies BA also belongs to R. If AB belongs to R and BA also belongs to R, then we say that it is a symmetric function. Okay, so in earlier example, if 1, 2 belongs to R and 2, 1 did not belong to R, so we say that it is not a symmetric function. Okay, so when AB belongs to R, BA also belongs to R, we say it is a symmetric function. What about reflexive? What about transitive function? If AB belongs to R and BC also belongs to R, then AC also belongs to R, then we say that it is a reflexive function. Okay, I'll just write it over here. When do we say it is reflexive? When AA belongs to R. Okay. When do we say it is a symmetric function? When AB belongs to R means that BA also belongs to R, then we say that it is a reflexive function. What will be a transitive function? Transitive. If AB belongs to R and BC belongs to R and AC belongs to R, then we say it is a transitive function. Okay, understood? Somebody was asking me to repeat, so I have repeated. When all these three conditions are satisfied, that is AA also belongs to R, AB belongs to R, BA also belongs to R, then AB belongs to R, BC belongs to R, and AC also belongs to R, then we say that this is a equivalence function. Equivalence function. Relation. Equivalence relation. So it is a equivalence relation. Okay, so we say that it is a equivalence. Okay, so we say that the relation is equivalence. Okay. Clear now? Okay. Yes, that is all for today. I think that is more than enough. Anything else? Let me see. Let me check. Anything remaining? No. So, no. So, we said it is only reflexive for this much. 1, 2, 2, 1, 1, 1, 2, 2, 3, 3. It is reflexive for that. Okay. Okay, inverse function. I just want to check nothing is left out. Yes. So you've taken all the sums. Yes. Let me check whether I have some extra sums for you. No, this is all. Yes, that is all for today. Any other doubt you have? Yes, just let me know. Yes, thank you, Pranita. Syllabus 7B, question number 8. Okay, domain and range of x and y is equal to x square when x and y are real are the domain. Okay, so just let me share the screen with you. Okay, y is equal to x square. So what will be the domain here? X and y are real, right? X and y are real, so domain will be real. Now range is how much? What is happening here? Y is x square. This means what? These are all real numbers. Okay, so C will be the correct answer. So real and real. Okay. Is it clear? What are the options given to us? 8 sum, no? Okay. Huh. Okay. In this question, what is happening? What is the two options that are given to us? Real and first option is real natural numbers. Second option is real non-negative reals. Third is reals and reals, and D is none of these. Now, what is happening in this case is it both are real. Okay, when you have x and y, both will be real. But what they specifically said is real and non-negative real. So we will choose that option. Why? Because it is more correct. Okay, C is also correct, but we will choose B. Okay, why? Because it is more correct. Is that clear? Any other doubt you have? Yes, Pratibna, you want set and proper set. Okay, just let me take you there. Okay, Pratidna, see. If every element of set P is also present in set Q, then we say P is a subset of Q. Okay. So how will it look like? So if I have this P and if I have Q, set Q, every element of P is present in Q, then we say that it is a subset. So suppose P is equal to 1, 2, 3, and if Q is equal to 1, 2, 3, 4, then we say that P is a proper subset of Q is that when there is at least one element in Q which is not present in P, then we say it is a proper subset. Okay? Is that clear? Okay. This is the symbol. A is a proper subset. I write like this. A is a subset. I write like this. Okay. Symbols are also clear, Pratidna? Himanshu, log 101 is not there. It was log 1 to the base 10. That is what I'm saying. You have to pay very attention to your first chapter. Log 1 to the base 10. It is not 101. Log 1 to any base. Remember, your teacher must have told you log 1 to any base is always equal to 0. Okay? Yes? Any other doubt? Somebody else was asking some question. Yes, Chaitanya. Thank you. Pratibha, thank you. 12th and 16th sum, Bala, from which chapter? Set or this one? You tell me. Okay. Yes. Okay. Just let me know. I will take it up also. Yes. Yes, that is all for today. Thank you for your patient hearing. Have a great day ahead. Take support. Yes. Thank you.